So in this video, I want to go over setting up the proper RPMs for the mill. So we previously did one for the lathe, and now we're doing one for the mill. Pretty much everything is kind of identical. The big thing that changes is the diameter. Now, well, previously with the lathe, the diameter was the diameter of the part spinning in that chuck. Now, the diameter is going to be the size of the cutter that you're using. The three cutters that we're going to go over today are the 3-inch shell cutter, the 1/2-inch tool steel cutter, and then the 3/4-inch carbide cutter. These are primarily what you're going to be using. I won't be surprised if over time we pick up more things like that, but these are kind of the ones you want to be using, okay? So we're going to quickly go through all three of them, and then we're going to call it a day, okay? So if you remember, surface feet per minute stands for how many surface feet per minute can either be cut with a piece of carbide or with tool steel. First one we're going to do is the 3-inch cutter. So we're going to rewrite this. It is, we always say carbide is around 250 surface feet per minute. So it's going to be 250 multiplied by 3.82, which should equal, I think, 955. Oh, it's going to be divided by 3 inches. 955 is the top here, and then we're going to carry the 3 over. So 955 divided by 3 equals 318. 318, we'll put RPMs. Okay, again, this is not a hard and fast RPMs. I noticed that this particular bit likes to run around probably 350 to 380 somewhere. So definitely play around with it. Make sure you're listening. You don't want to have a lot of chatter with this bit or any bit, but that's just going to get you really close. Okay. So the next one we're going to do tool steel, the 1/2-inch bit. So we're going to write it as 100 multiplied by 0.82, and then divided by 0.5. That's a bad looking 5. So this should equal 382. Or divided by 0.5, which should equal half that pretty much. Oh, double that. 764 RPMs. Okay, now that's pretty fast. I noticed that the tool steel stuff, maybe you might start kind of going on the lower end if you necessary, but that's a great place to start. Okay, let's do this last. We're going to do the carbide bit on steel, and it's a 3/4-inch bit. So we're going to do 250 multiplied by 3.82 divided by 0.75 for 3/4. So 250 multiplied by 3.82 is 955 divided by 0.75 equals 1273 RPMs. So as you're going to notice more with the mill that you're going to start seeing these a lot higher numbers, because we're going to be working with a lot smaller end mills and stuff like that. If you go and cut with like a 16th inch end mill, it's going to be running at like 2,000 RPMs. It's going to be going pretty fast. So definitely you do not want to get them mixed up. If you are cutting with a carbide, make sure you're using the carbide. If you're cutting with the tool steel, definitely do not do the calculations for the carbide, because you'll wreck that thing in a heartbeat. There's no way that 1/2-inch tool steel bit could handle 1200 RPMs. So that's kind of the quick and dirty about RPMs on the mill. So